In the last video, we looked at some problems related to some matrix algebra. In this video, I want to look at a number, how to find a number that's associated with every square matrix, and that number is called a determinant. Okay, so here's the definition. Associated with every square matrix is a number called the determinant of the matrix. So in order for the determinant to be defined, it does have to be a square matrix. That is, the number of rows and the number of columns has to be the same. 2 by 2, 3 by 3, 4 by 4, and so on. Now let's look at the definition for finding the determinant of a 2 by 2. So in the next definition, I have if A is a matrix with components A, B, C, D, then the determinant, so we denote a matrix with brackets surrounding the components, and with a determinant we use the bars or the absolute value bars if you want, and then the components. So here's a way we denote the determinant of matrix A, with the bars on A, B, C, D, and the operation is defined by simply cross multiplying. So it's A multiplies D minus B multiplying C. Make sure you do it in that order, otherwise you're going to get the wrong sign. We're going to look at some examples later on. Now for a 3 by 3, there are several ways to compute the determinant. I also want to point out, before I forget, I do have a video on my channel where you can find determinants using the TI-83 graphing calculator. I wouldn't recommend it for a 2 by 2 because it'll probably take you longer on the calculator than doing it manually. But if you have a 3 by 3 or a 4 by 4 or higher, the graphing calculator can give you the solution very easily. So you can click on my channel name if you want to look at that video, and it's the one dealing with using the graphing calculator to find the determinant. Okay, for a 3 by 3, I'm going to show you the algorithm. So the way it works is you can take basically any row. So there's 3 rows. Okay, so there's 3 ways there, or the components of any column. 3 columns there, so there's actually 6 ways there to do it. And then I'm going to show you another way in the next step here. So select the components of any row or column. And generally you want to select a row or column that has the most zeros, because the way this procedure works is what you're going to do is you're going to take the entries of the row or column that you select, and you're going to multiply by what is called the cofactor of that component. So obviously if the entry in the matrix is 0, 0 times anything is 0, so that's going to make it fairly easy. So always want to pick the entry or the row or column that has the most zeros. Obviously if they're all zeros, then the value of the determinant is going to be 0. Okay, because you're going to get all zeros. So you're going to take the components of any row or column, multiply by the cofactor, and then add them up. Okay, so for convenience, I'm just going to take the first row. So here's the way it works. You take the first component of that first row, that's A, there I have it, and then you multiply it by the cofactor. Well, what's the cofactor? Well, the cofactor basically is a determinant. So if you're dealing with a 3 by 3, the cofactors are going to be 2 by 2 determinants. If you're dealing with a 4 by 4 determinant, the cofactor is going to be a 3 by 3, and so on. So I want the cofactor of A, so I basically eliminate the row and the column that the component A is in, and what is left forms a 2 by 2 determinant, E, with components E, F, and H, I. Okay, so here I have it. And then for the cofactor, all you have to do is multiply that value by either a positive 1 or a negative 1. And the way you determine that is if the component is in an even position, you multiply by a positive 1, which doesn't change it. If it's in an odd position, you multiply by a negative 1. I discussed this briefly in the last video, but you determine whether it's in an even position or odd position by looking at the row and the column that the component is in. So A is in row 1, column 1. 1 plus 1 is 2. That's even. B is in row 1, column 2. 1 plus 2 is 3. That's odd. C is in the first row, third column. 1 plus 3 is 4. That's even. So A is in the even position, B is in the odd position, C is in the even position. You can see it's going to alternate as you go from one to the other. Okay? So in this case, I multiply that by a positive, so it's A times this determinant. Okay, then I take the next component in that row, which is B, and to get the cofactor, I eliminate the row that the B is in and the column. And what's left? The components D, F, G, I. There you have it. And because I said B was in the odd position, that's why I get this minus right here. So this is a minus. Okay. Clear this. Then I take the next component, which is C, and to get the cofactor for that, eliminate the row and the column, and I'm left with DE and GH. There it is. And C, we said it was in the even position, so this is multiplied by positive 1. Okay. So then to complete this, all I would have to do then is apply this definition up here and find the value of this 2 by 2 multiplied by A, find the value of this 2 by 2 multiplied by negative B, find the value of this 2 by 2 multiplied by C, and then add 3 numbers, and that would give me the value of the determinant. Now, notice if I had selected, say, the second row, then this would be a D right here. This would be a D right here where the A is, and I would take the row and the column, so the components here would be BC and HI, and D would be in the odd position, right? Because it's in the second row, first column. Those add up to an odd number, and then the signs would alternate. Okay. So we're going to apply this in the problems that I work here. Okay, so it says find the value of the determinant. Find the value of the determinant. So components are 2, negative 3, 8, and 3. So this is just a 2 by 2. So the first definition, you just cross multiply. So it's 2 times the 3. Subtract 8 times the negative 3. This product, okay? So this product right here, diagonally, minus the other product here. So this gives me 2 times 3 is 6. Negative 3 times 8 is a negative 24. But the negative over here in front, the minus makes it a plus, so it's 6 plus 24 gives me 30. So the value of the 2 by 2 determinant is 30. Okay. So in the next one, it's a 3 by 3. So I just want to I'm going to use the second algorithm that I went over. So again, I'm going to use the components of the first row. I could use first row, second row, third, or the first column, second column, third column. It works the same. Just follow the procedure. So basically, if I'm going to take the components of the first row, then I write down the first component, which is 4, eliminate the row, just cross it out mentally, or I'm doing it here so you can see it, and what you have left is negative 4, 1, 3, 4, so that goes right there. So it's 4 times this value, and the 4 is in the even position, so the sign stays the way it is. We don't multiply by that minus. Okay, for the next one, it's a 3, so take away again the row. Column, we have left 1, 1, 1, 4. So those are the components, and that's in the odd position. That's why this is a minus right here. It's a minus. Okay. Then we know with the next entry, negative 5. Let's put the minus 5 there. So to get the cofactor, I take away, eliminate the first row, and then the last column, take that away, what's left? 1, negative 4, 1, and 3. And that negative 5 is in the odd position, or the even position rather. Remember, it starts out even, odd, even. They alternate. So that's going to stay the way it is. Okay. Now, had this been in an odd position, then we multiply by negative, and this minus 5 would become a positive. But in this case, it stays the same. And then it's just a matter of evaluating these determinants here, these 2 by 2s, and multiplying. So on this first one here, I'm going to multiply the negative 4 and the 4, that's negative 16, and then subtract 3 times 1, that's 3. So that's minus 16 minus 3 is negative 19. So that's how I get the negative 19 here in this first parentheses. Then it's negative 3, and then again evaluate the 2 by 2. So it's 4 times 1 is 4. 1 times, subtract 1 times 1, that's 4 minus 1 is 3. So I get it here. And then in the next one we go 3 times 1 is 3, and then 1 times minus 4 is minus 4, but remember we subtract. So that becomes 3 plus 4, which will give me the 7. So 3 times 1 is 3, and then minus the 1 times the negative 4 makes it a plus 4. So that gives me 7. So then we just multiply 4 times negative 19, negative 76, minus 3 times 3, negative 9, minus 5 times 7, negative 35. We combine those, we get negative 120. So the value of the determinant is negative 120. So there's, again, like I said, 6 different ways to do it, because you can use any one of the 3 rows, any one of the 3 columns. Now the next method is also another method, an alternate method that you can use for 3 by 3s, and this in general only works for the 3 by 3, so keep that in mind. So I'm going to do the same problem here using this method. So how does this method work? Basically, you just write out your determinant, 3 by 3, and then take the first 2 columns and put them to the right. Okay, so notice 4, 1, 1, I put it to the right, and then the next column 3, negative 4, and 3. Okay, so it's the first and the second column in that order. And then basically the way it works is you're going to form 6 products. Okay, so starting in this upper diagonal on the left side, we're going to multiply this way here. So 4 times negative 4 times 4 is negative 64, plus, and then starting this right here where the 3 is, and down the diagonal. So 3 times 1 times 1, that's 3. And then you go to the next one, negative 5 times 1 times 3, that's negative 15. Those are added. And then we start in the lower corner here, lower left corner here, and we multiply out the diagonals this way. So 1 times negative 4 times negative 5, that's 20, and these are subtracted. These are subtracted. And then 3, go to the next one, 3 times 1 times 4, that's 12, and it's subtracted. So we have a minus 12. And then the last one, 4 times 1 times 3, that's 12. Okay, so now we combine. Add the negative 64 plus 3 minus 15 minus 20 minus 12 minus 12, and combine, and I get the same answer I got over here, negative 120. Okay, this will always work on a 3 by 3. Okay, and again, keep in mind that if you're doing some online stuff, or maybe multiple choice or something where the work is not required, the graphing calculator can give you the answer to these very easily. Okay, so that's just another way to evaluate. Now you can have some applications. Solve for x. So this is an equation. It could be a 2 by 2 determinant, or a 3 by 3, but you want to solve it. So very easy to do. All you have to do is just apply the procedure on the left side. It's a 2 by 2. So we cross multiply. 4 times x is 4x. Subtract minus 4 times x, which is minus 4x. Okay, and that's equal, of course, to the minus 48. Okay, combine this, the minus and the minus make it a plus, so this will give us an 8x equal to a minus 48. Okay, divide both sides by 8, So x will equal to -6. That's your solution. Now keep in mind again that the method for cofactors will work on any determinant. So if you're dealing with say a 4x4, the cofactors are going to be 3x3. So it's going to work the same way. You take the components of a row or a column and you multiply it by each the respective cofactor, apply the even odd method to determine whether it's a minus or a plus that you assign to that particular value, combine, and you can see it's going to be tedious because instead of evaluating 2x2s like in the example I did, it's going to be 3x3s. But if you're allowed to use a graphing calculator, it comes out fairly easy. Okay, so check that out. And again, if you have any suggestions, please post them. You want to see any other types of problems, I'm going to continue with the lessons here dealing with topics in college algebra. Actually here, this is actually the third chapter in our course that I taught. They are abbreviated lessons. It's not as detailed as I normally would go through in a classroom, but you have any suggestions or questions, please post them, and please subscribe. We'll see you in the next video.